333, but they look like, here, I'll pull out my homework and show you. 333 was our one with commutative and associative property. So you maybe used that on the test yesterday, but 331 had the giant 1 work on it.
I think they're asking
Oh, yeah, well,
this one's Layla
Davis has a check, but I think graph is in my pile potentially. So, I mean, guys, you know what you've turned in if you look in your binder, and it's in your binder, right? Like, if you haven't turned it in, it should be in your binder. Now, if your binder is not well organized, that's a different thing, which we're going to do a binder check here in like a week or two, probably right before Thanksgiving break. So, check it. No new homework yesterday. Today's homework is 411, and that's due tomorrow. Let's talk about the first in math competition that we are about to start. So this trophy right here is one that Phoenix won years ago before I was even here at Phoenix, but the top of it is about to start to change. So what we're going to do when homework is due is I'm going to coordinate it so that every class I teach, 1A, Math 2 is not going to count my 8th graders. It's too easy for them to all turn their homework in. There's 3 of them. That's too easy. So they don't count. But you guys, my Math 8 class and my other Math 7 class, so there are 3 different classes. What we're going to do is compare the percentage of people that turn in their homework on time. Now, what's nice for you guys is you have class first thing in the day. So, like, you can do it during AO or during extensions today. You could have it done, like, before you even leave school today. But what I need is it turned in by the end of the day tomorrow for it to be turned in on time. Which, this first check is going to kind of be easy for me because it's a weekend. Right? Either you got it in on time or you didn't. There's no, like, trying to sneak it in first thing the next day because it's going to be a Saturday. Right? If you are someone who's falling behind, though, and you feel like you could use some extra time at school, Mrs. Goldring has a couple students coming in on Sunday. So if you would like to talk with Mrs. Goldring about the opportunity to come in Sunday to get some work done, talk with Mrs. Goldring. She's offering up her own time to do that stuff. So if you do not have a copy of the paper with a bajillion dots on it, please grab it off the stool up here. Oh, what's the end point of the trophy going to classes, right? So, based on percentage of our homework completed, the trophy goes to whatever class. So let's say 1A wins the trophy from Friday. That counts as 1 trophy victory. The class that has the most trophy wins before winter break will get some sort of special prize or party or whatever you want to say. So, like, we'll probably, instead of having class one day, like, have a math party or whatever. So, DJ Hudcat might even show up for that. So, if you want that opportunity, might involve pizza, might involve ice cream, who knows, because by then it might be snowing, so we might need to do some sort of ice cream thing. But yeah, if you want that opportunity, do your homework and turn it in and put your name on it. No-name homeworks will not count. I am tired of my no-name board being so full of papers that apparently people don't know what their name is. Confuses me every time. All right, ready to talk about scale factor and similar figures? Anyone want to read for us? Anyone feel like reading? Deekshita, of course.
Today we will extend your study of ratios by looking at enlargements of
Reductions. Enlargements and reductions.
of
Geometric.
geometric figures. Think of a copy machine and what it does to a picture. When the enlargement button is selected, the machine makes every length of the picture larger or smaller by multiplying it by the same number, called the multiplier.
Ooh, that's a fancy name.
That multiplier is called the scale factor.
So, when we talk about scaling objects, it's a lot like when you grab a corner on the computer, right? Would this have been as easy for Deekshita to read if I had it this size? No, that would be silly. That would be a reduction of what the real object is supposed to be. And now I'm enlarging it to get bigger to the point where we can actually read it. So on our homework paper, and guys, I'm going to be looking for this when I check your homework. Turn your paper sideways. Right up here should be your name. Please check for your name right now. And on the side of it, I know, weird, but we don't have lots of space for notes today. I guess you could do it at the very bottom, but you're going to write other stuff at the very bottom. This is the shortest definition that I could give you. The scale factor. I should see everybody's pencils moving. I don't know why I have to invite some of you to pick up your pencil. The scale factor is the ratio of corresponding sides. What's it mean to correspond? Antonella? What do you mean? Like if I draw a shape here in the room, how could you tell if like a side corresponds to another side?
Like they are like the same length. Or like
Not necessarily the same length. You're right. If they were the same shape, it would be the same length. But with similar figures, they're not always the same. Sometimes they are.
Like when you enlarge them or like make them smaller, they would still be.
Yeah, like if it was the top, it is the top. If it was the right, it is the right. So yeah, the corresponding sides mean they go with each other, right? Top to top, left to left, right to right, bottom to bottom. So, first shape we're going to draw today, because what's their name? I forget their name. It's hard to talk about the situation if we... Karen! Of course, Karen. Karen is learning how to use a copy machine in her school's office. So she has this shape that we're all going to draw on our paper. So we can label it the original. So off to the left of your little graph area that I gave you here, if you want to write original. Sorry, I'll try to get my camera to zoom correctly. And guys, again, unless you were absent, like this should be on your paper. This is one tall at the side. It's got a length of 2 here, a length of 2 here. And then like one box on top. We got a little diagonal on the side. And then your task is to try and scale that by 300%. You want to tell me what you think is going to happen when we apply a 300% on a copy machine? Like, is it going to come out the same size, bigger, smaller? Like, what can we say about it? Lucas? Why is it going to become... Well, now, and can you be more specific than just a lot bigger?
I'm gonna say 3 times bigger.
Why are you saying 3 times?
Because so 300 percent is percent is out of 100. So 300 over 100, and then you just get rid of the zeros. That's 3 over 1, 3.
3. I could not say it any better myself, Lucas. 300% means 3 times as big. By the way, if we make it through our lesson, we get to go mini golfing.
What?
If we make it through our lesson, we get to go mini golfing. So I'm going to start with this top right corner, guys. And let's put that in the top right of our graph space so we kind of make it look nice. So if this length was 1 across the top and down the side, and Lucas is telling us we want to scale and make the new shape 3 times as big, what should the top of our new shape be? 3. So 1, 2, 3. I might change to a slightly lighter color if I got it so that we can still see things. I don't know if I got a slightly lighter color. Now it's going to look weird if I don't keep drawing in blue. So that's going to be 3. How far down the side? Well, you guys know what to do. Go ahead and keep going. Draw this scaled figure out. 1, 2. Hey, look up here real quick. Is this length, this diagonal length, is that the same as this length vertically? No. So if we're going to talk about this length, we got to call it one diagonal, right? Because it's bigger than just one. If I'm looking around and you don't have your pencil in your hand, I'm suspicious that you don't have this done yet. So if this was a diagonal 1 on the original, it's going to be a diagonal what on the new one? Diagonal 3, right? So there's 1, there's 2, there's 3. There's 1, 2, 3. 1, 2, 3. 1, 2, 3. I don't think. I mean, my shape connected back to itself.
But it was two tiny squares this size. So
You're right, Antonella. I made a mistake. Keep pushing. What did I do wrong?
You need like 3 more to this side.
Guys, look up here. This was on purpose. Antonella gets a piece of candy after class. This original length was what? 2. And if I scale by 3, 2 times 3 should be 6. This should not stop here. It should go on out, and it needs to be 6 long.
Like when I saw that you made the line, like right there, well, like when you saw that you finished, I was like, okay, he's just gonna make like that line, but then I realized you stopped, and I was like,
Sometimes I make mistakes on purpose because I just have too much candy and I need to give some away. So, if you were working in pencil, you could erase your mistake. First time I've used whiteout all year. Thank you, Antonella. I should have been using pencil because I planned on making a mistake and seeing who was awake. I also just like encouraging you guys to use pencils when I make a mistake in pen. Does this make sense that when somebody tells you, make something 300% the size of something else, that means 3 times as big because that's the decimal of 300%. Now do you guys kind of see how what we've been doing relates with what we're doing now? How if you are given a percent, you need to figure out what the decimal is? I'm not just crazy. I am crazy, but I'm not just crazy. So, down here to make sure that we get our notes filled in, down here, in order to figure out a scale factor, I left a part of your notes like empty, so you have to fill it in. We compare the sides in order of copy divided by original. So down here, I have Antonella, I have papers for you, but I gotta find them. Not Antonella, sorry. I'm on it. I was thinking about you because you caught my mistakes. The gaps made. I didn't leave any spaces here, but this is where we're writing the copy over original. So essentially, another way that we can say copy over original is like new compared to old, right? New compared to old. CPM likes to call it copy. I don't love using the word copy because normally when we say copy, what do we think about when we compare size to size? Anyone want to say why I kind of take issue with the word copy? Yeah, copy's normally the same thing, like same size. But what they're trying to get us to realize is like copy machines, and especially with computers and everything else, size can be changed really easily. So I don't love the word copy, but let's all just agree, copy doesn't mean the same size. Copy means the same shape, but different size is totally fine. So I got another one for us to try and draw out. Let's draw this one on our paper. So where you have space, I'm going to scooch this so then I can see my camera at the same time. So give yourself, draw somewhere where you have space to move to the right. Because I say we should probably start at the top left corner. How tall is this left side? Bless you. 4, right? So let's make our left side 4 tall. So whatever point you start, and guys, you don't need much more of this dot paper space. So you can like, you don't have to be super close up here. You can give yourself some space. So 1, 2, 3, 4. How wide is the top? 2. And then it stair steps. 2 down, 2 over. 2 down, 2 over. How long is the diagonal? 2 diagonal. How long is the bottom? 4. 1, 2, 3. Guys, let's go ahead and label these sides. Everything but the diagonal. Let's go ahead and label 2, 2, 2. Because the diagonal isn't technically 2. It's longer than that. But now, we're playing with the copy machine in a different way. Now we want to scale this 50% of the original. So go ahead and write on here, draw something that we're going to scale by 50%. If I'm doing 50%, will the new shape be bigger or smaller? Smaller. What fraction is 50%? Anybody? It's a half, right? So we could say, or 1/2 the original. 1/2. So go ahead and draw out your scaled shape that is 1/2 the size of the original. Ooh, I like that people are using highlighters or like making some sides a little darker so you can see things more easily. How'd you get a sticker of your name? Did you have this made or did you buy like individual letters? Oh, cricket. I need to get cricket. You're already done. It is not a race, but you can go ahead and look at the 4-4 if you want to go ahead and look at that one. We're going to do it together, but you can go ahead and do it on your own if you want. Guys, I don't like these rows. I'm going to have to switch the desks. It's too weird to walk up. Yeah.
These reminds me to my cousin from Venezuela, and it feels just weird.
It feels weird, I agree. I need to be able to like take a lap of the room and, forget about the center desk cluster.
Yeah.
Maybe at the end of class you guys can help me shove desks around, because it's easier with all of us than it is just me. So, 50% or half of the original. If I start at the top left, how tall is that left side going to be? Well, what's half of 4? 2. So we're 2 tall here. What's half of 2? Just 1. So my stair steps are 1 by 1 by 1. If our diagonal was 2, what's our diagonal going to be now? 1. If our bottom was 4, what's it going to be now? 2. So everything is half the original. It's cute. You could even, if you wanted to, we could draw it inside. If you want to make a cool kind of looking drawing, at least I think, you can draw the new one inside. Because if we get smaller, we can fit inside the original. Antonella?
What I did, I knew that the diagonal part was going to be 1. But what I did is I basically just did the 2 straight parts, right? Like this.
Yeah.
And I just connected them.
Nice. Yeah, the boo-doo-doo-doo-doo. So, if you have a highlighter, if not, you can underline. If you don't have highlighters in your binder, you're supposed to have highlighters in your binder. So, similar figures. This is what we're talking about today. Similar figures are the same shape, but not necessarily the same size. They can be. Like when I take your worksheets to the copy machine, I'm doing 100%, right? 100%, same size, run it through, give me exactly what I ran through the machine. But if you're any percent that is not 100, you're changing the size. I appreciate those of you that are sharing highlighters. Thank you for sharing. Please make sure if you are getting shared highlighters, you give them back. So what we're looking for here is the ratios for each pair of corresponding sides. So if you've got multiple colors of highlighter, kind of like what I've started in B, but we're going to do it in A and B, let's see what sides correspond. So like top to top, bottom to bottom, right? Like Antonella told us, as long as the shapes are facing the same direction. Antonella said top would go with top, bottom would go with bottom. So we want to figure out this ratio for each of them. So here, I'll do one with you on A, but then you're going to do A, like the rest of it on your own. So if I look at my top here and my top there, and I set up the ratio of copy over original. Copy over original. That should be equal to every other ratio. Copy over original. So show your corresponding. These would go together. So the 8 and the 4. Go ahead and on your paper, because I'm going to walk around in just a second. It's okay if you do not have enough highlighters to do all this. We can normally just kind of see it. But if you want to highlight all of them, it might help us. I'm out of colors. I'm going to have to use my pen. Purple. Got to give some love to purple. So for blue, if I set up copy over original, is 8 over 4 equal to the 4 over 2? Are these fractions equal? Yes, and we keep checking. For my bottom to bottom. Oh, I have 8 and 4 again. 8, 4, are these still equal? Yeah. So then for my left side, 5.6 over 2.8. Well, guys, remember, we said we can think about this as 56 and 28. Is 56 double 28? Yeah. And then the 4 and the 2 from the left side, because I did the 4 and the 2 from the top, are these all equal? Yeah. Sweet. So this checks out. All of our ratios are good. Check B. Do all of B's ratios work out? So I should see us starting to write down ratios below B to double check the copy over the original. Copy over original. Copy over, so the new over the old. Copy over original. I'm afraid to ask what this is. Interesting. It looks like snot. Why are you making it? Ask before touching people's stuff. Notice how I will tell you, something here fails. Antonella, have you figured out what fails? The 19 and the 30. Why does that fail? Because if we look at the comparison, like let's say the top to the top. Copy over original What does 18 over 36 simplify to? A half. So guys, what we're looking for is, are all the new ones, are all the copy ones half of the original? And most of them work. 26 over 52, it works. 8 over 16, it works. But as soon as we look at, is it equal to have 19 over 30? No. It fails. That did not scale correctly. Are there any questions on why that side being 19, like what should it be? 15, right? Because 15 would do what it's supposed to. Any questions? Let me double check, but I think we're ready to get out our computers. One more that we'll do on this worksheet. Go ahead and sketch this in your dot space. So how tall is that shape? 1, 2, 3, 4, 5, 6, it looks like. So you probably, hopefully, maybe have some space at the bottom of your dot space. If not, it's okay if you need to use graph paper. But 6 tall, right? So 1, 2, 3, 4, 5, 6. Ooh, I just have space for it. 1 wide at the top. 3 wide at the bottom. 3 tall. And whatever. Ooh, this diagonal is not a nice diagonal. So guys, we couldn't even really talk about what that diagonal is, because it doesn't actually go through the points nicely. I want you to turn to somebody close to you. If you want to talk, you don't have to talk. If we want to make this shape smaller, if we want to reduce this shape. Hey, hold on. You don't even know what you're talking about yet. What scale factor, and you can give me percent or decimal or fraction or whatever you want, what scale factor would we use to nicely reduce this shape? Take a minute. Chat with each other. What would be a nice scale factor when we think about this shape? To make it smaller. To make this shape smaller. What would be a nice number? Not right or wrong, but what would be nice? I haven't used random cards at all today. We probably should. Franco, you are not here, but if you watch the video, let's say that your code word is, I don't know, purple copy machine. I'm almost always I say purple. I don't know why. So actually, Franco did exactly what he should. He's out and he emailed yesterday and said, hey, what can I do? Like, when you miss school, if you want to be proactive, email your teacher, say, what can I do? Marina, can you tell me what you guys maybe talked about for a nice scale factor? Ooh, I love what you said. 50% isn't very nice because the 3s, right? Because those would become 1.5s. Isabella, do you have another? Layla Davis? Antonella?
I did 50%. It's probably not accurate at all. But
We can do it, but there's a nicer one. Mia? I heard somebody said it. Eli? Close. Give me a fraction that you actually mean. Eli wants to divide by 3. What fraction will divide by 3? 1/3. So if we make our scale factor 1/3, the new shape will be 1/3 of each of these numbers. So what's 1/3 of 6? 2. What's 1/3 of 1? 1. 1/3 of 1? 1. 1/3 of 1? What is 1/3 of 1? It'd be 1/3. So that's kind of hard to draw. This would be 1/3. And then we just connect it. All right, go ahead and pull out your Chromebook, student.desmos.com. Student.desmos.com. Student.desmos. This is way more fun than doing the homework. Where did it go? I had it. I lost it. So I did not assign it to you yet, but it's going to be called Dilation Mini Golf. All right, if you go to your assignments, you should see it. Dilation Mini Golf.
Is it like fun?
Is it like fun, he says.
Let's learn to get why do I need to put in a code?
You shouldn't need to if you log in with Google.
Yeah, that's fine.
Log in with Google. So, guys, one thing I want to make sure you understand. The scale factor is just like, and like it's a synonym, right? It's the same thing as a dilation. So, what we do here, the first slide you're going to see, when we hit try it, this new length is 1, 2, 3, 4 compared to the original length of 1. So what would that scale factor be if we get a 4 compared to a 1? 4 compared to 1, it's 4, right? The scale factor here is 4 because the new length, guys, not just gray and black combined, right? The new length is 4 compared to the original length of 1. So check it. CB is our original length. When I hit try it, the new length is C to the cup. The new length is C to the cup. So that's 4. That's why it's a scale factor of 4. So I'm going to move this back off that screen to make sure that we're all getting on here because I only see 3 of you so far. Student.desmos.com, then log in with Google. If any of you think that you weren't here when we did this the first day, I think, yeah, Amanda, you might need to come get the code from. No, you're part of the class. So log in with Google. So go to student.desmos.com, log in with Google. And then click on the Dilation Mini Golf.
So open a new tab. Student, S-T-U-D-E-N-T, and it will probably pop up. Dot, the period, Desmos, D-E-S.
part of my class, your name was only Lucas. So I wonder if somehow you have two different. Refresh your page. Try that, Lucas.
Wait, is it combined?
I could try to kick you out of the class so then you could rejoin it, Lucas.
Wait, Mr. Hudson, is it combined like the gray and the black? Let's go back.
Yes. So the new length is the entire length.
Oh, it's 5. I got it wrong.
Lucas, LS1006. Log out and log back in. I mean that, or I can remove you and we can try to re-add you. Anyone else having issues with it's not showing up for you? Franco, if you are still watching the class video, you should be able to go into this. I'm going to leave it unpaused. So email me if you have any issues getting to this activity, but you should be able to do this even at home. All right, at this point, we should probably move chairs, like move our